Alright, what up my glip glops? We are doing another review. By the way, if you're Patricia Nguyen or no Patricia Nguyen, tell her to go to the front desk, because this is the second video that she's gotten called out because she's not riding the bus. Come on, girl. Get it together. We got kids to feed. I don't know. Alright, here we go. First part, I want to find out what all of this crazy jazz is. Well, let's look at my A and my B. I know those first. My A, the number on the outside, is going to be which one of these? My initial value. Yes. So this is my initial. Oh, I'm writing too big. Not going to be able to fit it in. Ah! Value. Another word for initial value is my y-intercept. Yeah, boy. Good, so that's my initial value. My B is my base, because it's all about that base. I know, so funny. The cringe. Also known as my rate. My base or my rate. Alright, this little X thingy, that is my exponent. Exponent. And it's also my independent variable. A-B-L-E, that's how you spell that. Independent variable. That spells V-A-R-I-A-B-L-E for those of you that are going to complain about my handwriting. It spells variable. If you need to stop it and listen to me spell variable again, do it. And then this one is my dependent variable. I'm going to abbreviate variable VAR because no one wants to write all that stuff out. So that's my general equation. If you don't know this equation by heart by this point, shame on you. You must have been sleeping in class like half of our class. Wake up! But you need to know this equation. Alright, so the first part, the actual math part. I want to convert the square root of 72 into three different forms. Expanded form, simplified form, decimal form. Well, expanded form, I do my upside down division thing. So I take my 72 and I divide it by a small prime number. Well, it's even, so let's divide by 2. 72 divided by 2 is 36, because Mr. Venture's smart, don't need no calculator, don't need no man, strong, independent woman. Divide by 2. 36 divided by 2 is 18. 18, I can keep doing this because it's keeping being even. Divide by 2 is 9. Oh, can't divide by 2, but I can divide by 3. 3, and I get 1. There we go. So these are all my numbers. So my expanded form would be the square root of 2 times 2 times another one. 2 times 3 times 3. That's my expanded form. Remember, if I have a pair, the pair goes on the outside, the pair is on the outside. It's like twins. If I have one that I like more, I keep one and I kill the other one. Kill that one. Kill that one. So my 2 comes on the outside. And then my 3 comes on the outside, and left over I have a little only 2 right there. And I can simplify this anymore. 2 times 3 is 6, so this is 6 times the square root of 2. Now really all of this math is useless because I could just plug it into the calculator. Why didn't you tell me that before, Mr. Venture? Because I'm evil! So I do the square root of 72, that is 8.48 blah 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 blah. And if I do 6 times the square root of 2, I get 8.48 blah 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 blah. So I know I did it right, and so my decimal form would be 8.485 blah 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 blah. But I don't care about the blah 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 blah. I only care about that. Word. Alright, simplification. Hopefully you guys are experts at this by now. I have my numbers, my coefficients. 36 divided by 12 is 3. Now, when I'm dividing, I subtract the exponents. When I'm dividing, I subtract the exponents. So I have x to the 7 minus x to the 5, so that is x to the 2. Then I have 2 minus negative 8. Don't tell me that that's negative 6. I have 2 minus negative 8. So this becomes y to the 10. And that is my simplified version. It's that easy, ladies and gentlemen. Now, my next one, I am multiplying. My base operation is multiplication. So what is negative 7 times 4? Negative 7 times 4, I get negative 28. Am I being silly? Is that right? Why am I being silly? Yeah, no, I'm being silly. Okay. X to the 3 and x to the 7, when I'm multiplying, I add the exponents. So I have 3 x's over here, x, and 7, 1, 2, 3, 4, 5, 6, 7. So I have 3 and 7. I total have x to the 10. And then I have 4 y's over here, 1 y over here. I have y to the 5th. And that is how I simplify that. Wow, I'm running out of room already. Writing too big for all you blind people out there. Alright, number 3, the function y equals blah, 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 blah represents an exponential what? Okay, well, I want to know if it's growth or decay. Well, I'm going to actually answer this one backwards. I want to know what the rate is and the initial value. Again, this is in form like this up here. Y equals a, b, x. So, I'm going to just write that underneath it. Y equals a times b to the x. Well, I know my a is my initial value. So my initial value is 0.49. My b is my rate, so my rate is 2.1. Now for growth or decay, I only care if it's bigger or less than 1. For growth, it is bigger than 1. For decay, it is less than 1. Alright, so for this one right here, my rate is bigger than 1. 2.1 is bigger than 1, so this is growth. Pretty easy stuff. Number 4, very similar. I'm going to write my A and my B underneath. So my initial amount now is 2.1. My rate is 0.49. So the rate is less than 1, because 0.49 is less than 1. Therefore, it is decay. These were just notes up here for you. I would probably have that memorized. Alright, number 5. I want to know linear, quadratic, or exponential. Well, again, I have many ways to do this. I'm going to show you the easiest way. Remember that linear, I add or subtract. Linear, I add or subtract. Exponential, I multiply or divide. And quadratic is everything else in between. This says everything else for all you people who care that I write tiny. Everything else. So linear, I add or subtract. Exponential, I multiply or divide. Quadratic just is everything else. So let's look at this one right here. From 1 to 4, how did I get there? Well, I either added 3 or multiplied by 4. From 4 to 16, how did I get there? Well, I either added 12 or multiplied by 4. And now I'm starting to see the pattern. I multiply by 4, I multiply by 4. So if I multiply by 4 again, 16 times 4, bing, 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 I get 64. So because I multiplied, this is exponential. Now I'm going to abbreviate EXP. Alright, my next one, from 5 to 7, I added 2. I really didn't multiply anything there. That would be pretty hard to multiply. Here, I added 2. Oh, well, I've caught on the pattern. If I add 2 to 9, I get 11. So this one is linear. Alright, and finally, my next one. Here, I add 3. It'd be pretty hard to multiply something to get there. This one, I add something different. I add 5. And this one, 14 to 21, I add 7. And what you'll actually see for quadratic is if you add, if I look at the difference between the difference, if I look at the difference of these numbers, how did I get from plus 3 to plus 5? Well, I added 2. From plus 5 to plus 7, I added 2. That's where my pattern for quadratic comes from. It's the second difference. But again, I think it's a lot easier to see, okay, am I multiplying? Yep, that's exponential. Am I adding? Yep, that's linear. Am I multiplying or adding in this one? Nah, so it's my quadratic. Nah, man, that ain't me. Quadratic. Quadratic is a gangster. Alright. If you didn't get it, rewind and watch it again. Alright, linear, quadratic, exponential growth, exponential decay. Well, this is really review. And if you haven't caught on by this point, the first 3 letters in linear spell line. So which one of these is a straight line? Yeah, duh. The first one. Linear. Linear, straight line. Linear, straight line. Say it with me. Linear is a straight line. Again, linear is a straight line. Hopefully you're finally getting that by now. If you're not, we might have to see you next year, which would be embarrassing. Alright, this one. I know it's exponential because it's only 1/2 of this part, because that's what my exponential function looks like. It looks like a C going that way. Alright, well, as I read from left to right, am I getting smaller or bigger? My values are getting smaller, 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 smaller. So which one is that? Is that growth or decay? That is decay. So this is exponential decay. Oh, again, this one is exponential because I have the half C, but it's going the other way. Are my numbers getting bigger or are they getting smaller? Well, these are getting bigger, so this is exponential growth. What leaves the only one left is quadratic. And remember, quadratic forms my little U shape, which has a fancy name called a parabola. And this is my parabola. So this one is quadratic. Yeah. We're crushing it. Alright, number 7. Which function best represents a population which decreases by 1/3 in size every hour? Alright, well, decreases by 1/3 in size every hour. What does that tell me? Does that tell me my rate or my initial amount? Well, decreasing by 1/3, that tells me my rate. That's telling me my rate. It's telling me how quickly I'm decreasing. Well, remember, I have y is equal to a times b to the x, and this is my rate. My rate is always the thing that is with the exponent. So which one of these has a 1/3 then raised to the exponent? This one, no way. It has times h squared, not even close to what we've been doing. This one has a 1/3, but it's not raised to the exponent. Nope. This one has x and 1/3 in the exponent, but I need 1/3 down here as my base, raised to the exponent. So now this one, well, I have 1/3 raised to the exponent. This is the only one that fits. So my answer is D. Chugging right along. Graph shown represents a population of bacteria over time. Which of the following is not a true statement? So I'm looking at my graph. I see I got time in hours down here and a bunch of bacteria growing. And I'm looking, this sort of looks like it is an exponential function. Alright, which one is not? Which one is not true? The initial population was about 50 bacteria. So my initial is this amount right here. Well, it looks like it's in between this and this. Well, this is 200. If I go up 2 blocks to get to 200, this must be 100. So in between, this must be 50. So it looks like, yeah, it might be about 50. Someone's coming in. Everyone panic. Who is it? Oh, no, it's just the custodian. Hi, custodian. Hello. Oh, you're good. Don't panic. Come in. You're good. She freaked out. So now the population increased 100 every hour. So I go from here to here to here. Well, did I increase 100? Right, this is my first hour. This is my second hour. Did I increase by 100? I went from 50 to 100. No, no way. And even look at this. If I went way later, I'm starting at 400 over here at hour 3. And at hour 4, I'm at 800. Did I increase by 100? No way. So this is which one is not true. Okay, and I look at the other ones. Population doubled every hour. Yeah, that looks like it's doubling pretty much every hour. Population at 6 hours would be 3,000. Yeah, that's looking like by the time we get up here, it's going to be somewhere way up there. So I'm good. Number 9. Mr. Bell purchased a famous and rare baseball card. Ooh. You good? For $125, right? That right there, ignore math. That right there, that hardworking lady picks up all y'all's trash. So if you're leaving trash on the ground, this ain't your house. We are not your mothers and fathers. We're not going to pick up your trash. Someone else has to do it. Pick up your trash. Okay, I'm getting off my soapbox now. Experts estimate that the value will increase by 8.3% per year with an exclamation point. Wow! The following equation can be used to model the value of the baseball card, blah, 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 blah. So I have this equation telling me how valuable this baseball card is going to be. And I want to know how much the baseball card will be worth in 18 years. Well, 18 years, is that going to be my V or my T? It is my time. So this is actually 125, parentheses 1 plus 0.083. Oh, I put an extra 0 in there. Ignore that 0. To the 18. This is an 18. And again, if you're the kind of person who has to keep on asking, wait, what did you write? What did you write? Maybe you need to reevaluate how much you're paying attention to what I'm saying. You should be paying attention to what I'm saying just as much as I am what I'm writing. I'm saying a lot more important things than I'm writing. Pretty much every single video I tell you what's going to be on the test if you're listening to me. I always do that big hint, hint, wink, wink. So if I'm solving this in the calculator, I plug that in. And I can do this in my home screen because I don't see any x's. Plus 0.083 to the 18th power. And I get, wow! It's like expensive now. So this is about $525 after 18 years. Alright, next one. So, number 10, a population of 2,348 increases by 4% every year. Alright, well, when I have percentages, remember, I don't like percentages, I like to work in decimals. So I'm going to take that 4% and divide by 100. And I get 0.04. Now to write a function for this, I start with y equals my original amount, 2, 3, 4, 8. And in parentheses, I always start with 1. I always start with 1. Now I'm either going to add or subtract this value right here, my rate. Well, am I increasing or decreasing? I'm increasing, so I'm going to add. I add my 0.04, and I can raise that to the x power. It's that easy. I start with my initial amount, start with 1, I either add or subtract, and then I add my percentage. But remember, I always have to divide by 100 to get my decimal. So this is my function. This goes right over here. There's someone else in the room right now who's watching me make the video, and he's just dancing like a fool. I'm not going to mention his name. Alright, I want to know about how large the population will be in 5 years. So I do the same thing, but instead of an x, because my x is my time, I do a 5. And again, you can plug this into the calculator, just like you did on the last problem. Alright, so we've had 3 problems, right? Or we're about to have our 3rd problem. The first one, it gave us the equation. The next one, we had to make the equation. This one, again, we're going to have to make the equation. And actually, I want you to do this one on your own. So if you're watching the video, pause it, because you had two examples right here that are very similar. And now I'm going to have a classic card that increases by 15%. And I want to know the function. I want you to pause it right now and try and write the equation. Because if you can't write this equation from scratch, you're not going to do well on this test. You have to be able to do this on this test to do well. So pause it, try it. Good, welcome back from the pause. And the equation is this right here. Again, if you have a question on that, ask the teacher or look at the examples before, because it's the exact same process over and over and over again. I'm increasing, so I add. I start with 1. I turn this percentage into a decimal. Here's my original amount. It's the same thing. Wow, we're already halfway through the review. We're crushing it. All right. An exponential function contains ordered pairs as shown in the table. What is t function? What is t function? Who put this t there? Silly. Funny face. T. That made for really funny. Alright. What is... I don't even know what the question is asking me anymore because I was being stupid. Exponential function contains ordered pair. What is the function? I really don't even know what this is asking about. What is the rate? What is the... what is it asking me? Alright, well I think... Let's just look at this table and see if we can figure it out. I have this table. How did I get from 25 to 150? Well, I either added 125 or I multiplied by 6. How did I get from 150 to 900? Well, I either added a really big number, that would be plus 750, or I multiplied by 6. And I'm starting to see my pattern, multiply by 6. To get here, again, I will multiply by 6. And my final one, multiply by 6. Right, well, let's see if I see that number over here. Well, I don't know what the question is asking me, but I see a 6. I found a 6. I say it's 6. Whatever. Number 13, which equation represents the function shown in the graph? What is the y-intercept? Ooh, these answers are really weird looking. So I want to know the function, right? Because math is fun. And then I want to know the y-intercept. Well, the y-intercept is easier to find. Remember, this is my y-axis. So I want to find where this line crosses the y-axis. This is at 1. So I can eliminate this answer choice, B, because it said that my y-intercept was 0. All these have 1 on them. Alright, well, again, this one is pretty easy to solve just by process of elimination. What type of graph is this? Well, you can see that it goes on this. It's my little C shape, so it is my exponential. Now, is it exponential growth or is it exponential decay? Well, I'm getting bigger, 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 so this is growth. Alright, well this one, that's not an exponential function, that's quadratic, so I know it's not that. This is exponential, and it's growth because my b value is bigger than 1, 4 is bigger than 1, so maybe. This one, it's exponential, but my b value is less than 1, it's a fraction, so this is actually decay, and I wanted growth. So this one is C. Number 14, write an equation that models the table. Alright, well again, there are many ways to do this. I showed you the first way to see what I'm doing. From 1 to 4, how did I get there? I either added 3 or I multiplied by 4. From 4 to 16, I either added 12 or I multiplied by 4. And I see that I multiply, 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 multiply. And so I can tell that this is going to be an exponential function. Now, it gave you the hint to use exponential regression, so I'm going to do that. So, I go to Stat, Edit, and I got all these points in here, so I want to get rid of them. Go up and clear them. And I'm going to plug my x's in, so 2, 4, 6, 8, who do we appreciate? 10, 12. And then in my y's, I have less of a fun pattern. 1, 4, 16, 64, 256. I can't read the next one, but I know that's 1,200 or 1,024. All right, now we already know it's exponential, so I'm going to go back to stat. Instead of edit, I'm going to go to calculate. We used to type in linreg, but this is linear. Don't want that. Don't want quadreg, because that stands for quadratic. Well, let's just look around, see if we see anything that looks like exponential. Oh, wait, there it is. EXP. That's why I've been sort of writing this, EXP, exponential regression. So I click enter, 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 and I have my equation. My equation is y equals 0.25 as my initial value times the 2. It's my base to the x. Now I can answer all these. So I go up here. My growth rate is 2 because that's what's with the x. My initial value is 0.25. This calculator method will always work as long as you choose the right thing. I first saw, okay, I'm multiplying to get every value. That way, I know it's exponential. Ding, 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 ding. Now, I can go to my calculator, plug in the values, and I am golden. I'm Gucci, man. Alright, finally, we're getting close to the end. Table shows investment. Ooh, money. Based on the data in the table, what will the value be at the end of 7 years? Alright, so I want to come up with an equation for this. Well, this one's actually easier to do by hand. Look at this. How did I get from 150 to 300? Well, I multiplied by 2. Let's see if that pattern continues. Did I multiply by 2 here? Yep. So my rate is looking like it's going to be 2. I know it's going to be exponential. Remember, exponential, I have y equals a times b to the x. Who just knocked? They can't come in. Someone just knocked. Well, too bad. Sorry. So, I have y is equal to, my initial amount is 150, because that's what I start off at. My initial amount is 150, times b, which is 2, raised to the x power. So that's my equation, because my initial amount, I started with 150, my rate is 2, and this is my equation. Again, if you wanted to go to stat, edit, you would get the same thing. You could plug in all of these values. You could go here, plug in all the values, then go to stat, calc, and you could go down to exponential regression and get your equation. This one wanted to know how much money I'll have after 7 years. So I have y is equal to 150 times 2 to the 7th power, because 7 is my years. So this, well, I can plug this into my home screen now that I don't have any x's. 150 times 2 to the 7. Wow, that's a lot of money. 192.00. So I have $19,200 after 7 years. Bam! Alright, Gina. What you doing, Gina? What you doing, girl? Just purchased an antique desk. Wow, Gina, are you old? You're antique. Gina purchased an antique desk worth $8,000. $1 million. The equation this models the value of the desk after t years, which of the following best describes the meaning of the value of 1.03 in the equation. Alright, well, usually I have something that's like this. 8,000. Remember, I always start with 1 plus something. Well, how did I get to here? Well, I added 0.03. Right? This is, I'm working backwards from this. Usually I start with 1, I add something, and can simplify it to this. This way, they already simplified it. Alright, well, so let's see. The value of the desk increased by 1.03%. No. Remember, this is my percent. And if I multiply by 100, this is 3%. So it's not increasing 1.03%, it's increasing 3%. It's definitely, oh, this is a decrease. Increase, no way. Value will increase by 3%. Well, maybe. the value will decrease. No, if it was decreasing, remember, this would be less than 1, and it's bigger than 1. So I have found my answer. Right? You can work backwards from here this way by saying, okay, what did I add or subtract to 1 to get here? I added 0.03. Well, that percentage is 3%. All right, last page. We're in the home stretch. We're sprinting now. Here we go. I want to match each function to the table. Ooh. Well, if I really wanted to, I could go through and plug all of these into my calculator. Well, I see they all start at 20. These two are going to be increasing, and these two are going to be decreasing, right? Because this is bigger than 1, smaller than 1, smaller than 1. They all start at 20. Well, all my things start at 20. Well, I'm going to teach you a trick so you don't have to plug it in your calculator. Look at these two rates. I know these are increasing. Which one is going to get bigger faster? A 1.1 or a 1.5? Well, 1.5 is bigger, so this one's going to be getting bigger faster. So let's go over to my tables. Which ones are getting bigger? 20 to 18? No way. 20 to 15? No way. 20 to 22? Yup. 20 to 23? Yeah. So, which one got bigger faster? This one clearly got bigger faster. It went from 20 to 30, while this one went from 20 to 22. So the bigger rate is the bigger change. So this one is B. Therefore, my other one has to be A. Okay, my next one, I know I'm decreasing. Well, which one's going to decrease faster? This one is way less than 1, so this one's actually going to decrease faster because it's further away from 1. This one is almost 1, so it's going to be decreasing not very much. So I go down here. Here are my two decreasing. I know I decreased from 20 to 18, 20 to 15. Which one decreased faster? Because this one was further away from 1. This one decreased faster, so this one's going to be D. And this one's going to be C. Now, if you didn't understand what I just said, try watching it again, listening to what I said. I'm just talking about how big the rate is. And if you still don't understand that, that's fine. Take these values, plug them into your stat. You can always do this. I'll do it with the first one. I just don't want to do it for all of them because that would take a long time. I can take this. I go -1, 0, 1, 2. And I can go over and do 18.2, 20, 22, 24.2. And I can go to Stat, Calc, go down to Exponential, because all of them were exponential, and calculate my function that way. And it'll give me the answer. Now this one's a little weird because the numbers weren't picked very well, but I have 20. And that's 20.0007, which is really close to 20. So I know that this one's going to be this one right here. And this is 1.0999, so it's real close to 1.1, which is what I got for this one. So again, you can go through and do stat, edit, stat, calc, and find all the equations. I was just trying to use a shortcut. Alrighty, next section, match the function with the graph. Oh, this is a little bit easier. Alright, so this one, I know it starts at 1, and it gets bigger because it's growth. Well, let's see if I can find it. This one starts at 1, but it's getting smaller, so that's going to be decay. This one starts at 1, gets bigger, maybe. This one starts way up top, no way. This one starts way up top, so my only answer choice is B. Next one starts at 5, so higher, and is getting smaller because my rate is less than 1. Because my rate is 1/3. Ooh, excuse me, I burped. Oh, it smells bad. Ooh, I'm so glad you're not here. This starts at 5 and gets smaller. So this one, nope, starts lower. Nope, starts lower. Oh, this starts at 5, but I'm getting bigger, so no way. This one starts at 5, oh, and I'm getting smaller, so this one is D. Alright, next one starts at 1 and gets smaller. So this is my starting, and this is my rate. Because my rate is less than 1, I know it's decay. I'm just writing it out. This is what I've been saying this entire time. So it's less than 1, so I start at 1, I need to get smaller. Good, found it. And by process of elimination, I know that the last one is C. Let's check it. This is starts at 5. Good, starts at 5. And it gets bigger because R is greater than 1. So this is a growth problem. Starting at 1, gets bigger. Bonk. I'm Gucci. Alright, last part. Determine and write the exponential function for each table. Ooh, exponential, you say. Alright, you want to state whether the exponential function is a growth or decay. Alright, well, I've done this like 1,000 times by this point. If you can't do this in the multiple ways I've taught you, I need you to go back and rewatch the video. I'm not going to show you how to do this. I'm literally just going to put the answers. I'm going to go through and I'm going to put the answers. So pause it right now, use your calculator, and try and do this. Or you can just look at the tables and find out. And that's what I'm going to do. I know that this one is growth because it's getting bigger. I know that my initial amount is 1, and I'm multiplying by 5 each time. So this is 1 to the 5. This one, again, is growth because I'm getting bigger. My initial amount is 2, and I'm multiplying by 4 each time, so my rate is 4. This one is getting smaller, so it is decay. I'm starting at 1,024, and I'm dividing by 4 each time, so this is going to be 1/4 to the x. This one, my initial amount is 3, so now I know it's going to be 3. And going forward, I am dividing by 2. So my rate is 1/2. I'm getting smaller as I go down. So this is decay. Now, if I just totally lost you, that's fine. Go back, look at it again. Or realize that you can still plug all of these into your calculator. Stat, edit, stat, calc, and it'll give you this. Stat, edit, stat, calc, it'll give you this. Stat, edit, stat, calc, stat, edit, stat, calc. And it will give you these values. Promise you it'll come out to these exact things. Except these will be decimals instead of fractions. But you could turn them into fractions. I just know that this is the initial amount, 1, and it's growing by 5 each time. So 5. Initial amount 2, growing by 4, so my rate's 4. Initial amount, dividing by 4 each time, so this is 1/4. Initial amount, dividing by 2 each time, so my rate is 1/2. Alright, Gumbies, that's it. There's no more math. We're almost done with school, kiddos. You should be hyped. Just the STAR test, and then some finals, and we are out of here, just like Mr. V is on this video. Peace!